Hey, good morning. Just want to thank Mike and Mark and all the folks at ARC for actually inviting us here this week. This has actually been one of the better events that I've been to in recent years, getting to see all of the stuff that other industries actually participate in, get to see some of the same issues, especially around cybersecurity and stuff that you guys are seeing in your industries that we see in our industries as well. Well, what I want to do today is I'm going to, give you just a brief slide about who we are, who Duke Energy is, and really try to give you a history of how we got to this open field message bus concept. And it took us a little while to get there, to figure out exactly how we wanted to approach it. So I think a little bit of the history of that is really relevant. And then really just try to give you a brief introduction to what OpenFMB is and how you guys can actually pick up the same concepts that we've done in our industry and apply them to across the board. It's really easily to pick up and move. So who in here actually knows who Duke Energy is? Oh, good. We actually, most of the folks in the room, that's good. Yeah, we're just a little small utility, We're actually one of the largest investor-owned utilities in the United States. We cover, 7 states now with our recent merger with a gas company, Piedmont Natural Gas. We have 7.4 million customers. You see that number come out a lot, but really 7.4 million doesn't really cover the number of customers. That's really the metering endpoints that we have, like basically sending out a customer bill. If you think about that, that's really approximately 25 million customers that we provide electric service to. And 25 million customers, that's about 13.5% of the population of the United States that we do. So we've got a lot of folks. We've got 1.5 million natural gas customers that we provide natural gas service to in 5 of the states, I believe, if I'm not mistaken. We've got over 50 gigawatts of electric generation, that really keep the base load power on the grid flowing. But we've also got nearly 3 gigawatts of renewable energy projects now. North Carolina alone we're like in one of the top 3 states in the United States for new solar installations. So it's something that Duke Energy is really pushing for, is this renewable energy. And we've got over 30,000 employees in our company now. I think it's probably about 32,000 or so at this point. But the group that I work in, we're less than 20 people. We're a really small R&D group that's inside of Duke Energy, where we get to think about what the grid of the future is going to look like. How 5 to 10 years down the road, what does this look like? How do we stay in business, as an electric utility? All right, let's go through a little bit of the history of how we got here. We started back in 2007 with some of our smart grid deployments, if you want to call it that. But that's really just like it's the AMI metering systems, where we put, meters out there. We put communication devices out there that we called a communication node at that point. But we put these devices out there so we could get better visibility into what the power usage was all the way down at the residential household, give better fine-grained power usage that we could feed back to the customer at that point. Typically up until that point, your meter got read once a month at your house. Somebody would walk up to your meter and look at it and write the number down. Well, putting the AMI systems in, it allowed us to really get a finer grain control. We would get like 15-minute interval data off of the meters that we could provide back to the customers, so they could really see a little bit better of when they were using electricity in their home, so that they can make some adjustments. Well, going on over through the years, we started deploying a lot of other smart assets out onto the grid to help us understand what's going on. We put out line sensors. We started installing more grid scale solar energy. Grid scale batteries, if you will. We installed our own weather sensors in some place to get a better localized view of what the weather was at a particular location. But we did a lot of these things over the course of 5 years here, putting things in, seeing how they work. Does it make sense? Is it something that we can actually utilize going forward? Well, putting all that stuff in, it allowed us to connect a lot of things up. We put those communication nodes out that we use like for the AMI system. We use those for a lot of our other systems as well to backhaul data in. So it allowed us to really connect a lot of the places in the grid that we didn't normally have visibility to, like Mike was alluding to earlier. It allowed us to see, what was actually happening on the grid. Well, it's all well and good that we got things connected up, but what wound up happening is, and it's probably the same thing in y'all's industries, is we wound up with a bunch of silos of data, where we wind up with the asset in the field has to talk to a particular piece of software in the back office that has to talk over a particular, communication structure. So, and everything is locked into those silos, and there was really no sharing of data until you got into the back office. And at that point, you could, bring in the IT system or the IT software people inside of Duke and do large projects that were, really expensive to connect all of this stuff up, across our enterprise service bus that we have in the back office. A lot of that is very, very expensive. It's one of those things, if you look at Duke Energy as a whole, we have over 1,500 applications in our back office, and we spend over $100 million a year just maintaining those applications. So it's, any time that you could, potentially, take some of that cost out of that, we're all for that. But one of the biggest things that, drove us to this is, out at the actual edge, we have zero interoperability between devices at the edge. Meters, couldn't talk sideways, if you will, to the transformer that's near them, to a recloser that's just down the electric feeder. There was no visibility at that, at that grid edge. So without that interoperability, it kind of leaves the asset stranded, if you will. So, we really needed that field interoperability, and there were some of the things that we considered that very, very important if we want to continue this deployments of these things. The distributed energy resources that we were actually putting out in the field, some of the use cases that we were looking at the, at that point, and how we're still continuing to look at them, they needed very, very fast communications between the devices to be able to pull off functions. And the whole backhaul through the primary, those siloed systems into the back office, and then trying to push things back out in the field, you're just way too late, and data winds up being very stale. Like I mentioned a minute ago, the back office integration costs are just, ridiculous when it comes to, putting some of these large systems in. It takes a long time. It's something that you would like to be able to connect things up in, a few weeks, and it winds up taking 6 months to a year project to get all the stuff in. And that's just really, it's not viable at that point. And also another thing that we really ran into was, all of those devices that we were putting out in the field, they conform to some open standard, whether that, they talk DNP3, they talk Modbus, they talk C12 for meters, or 61850. They all conform to those standards, but that just because they were, conforming to standards does not mean that they're interoperable. I couldn't take, a meter, from one vendor, pull it out, take a meter from another vendor and put it in and expect it to work any longer. They didn't work because they had to be in their own proprietary siloed systems. And for us, it's a non-workable solution being able to do that. So what we were going to do is we said, okay, well, how can we go down this road? How can we figure out, how can we make some of these things work? And since we had, some of the pilots of the large-scale solar, the large-scale batteries, we're like, well, let's see if we can take some of the, the invariability of the solar and see if we can, utilize some of the other assets to counteract some of the dynamics that it's pulling off. most people, when you think, okay, I'm going to stick me, this solar farm in, I'm going to get this nice, pretty, bell-shaped curve. The power's going to ramp up during the day. It's going to flatten out kind of the day, and just the sun goes down, it's going to drop off. Be kind of predictable. Most people think that's what it looks like. Now, in our case, you see the power curve is actually going negative here. That's because we see that as power coming back towards us. Instead of us generating and pushing out, it's power coming back. So I just wanted to make sure I explained that a little bit. But that's what most people think that a solar, it looks like. It's this nice little pretty predictable curve, when most of the time it looks more like that. You got clouds passing over all the time, and the solar's bouncing around all over the place. It's very, very unpredictable at that point. And it's not something that from a utility electric generation, we value that stability and, in the grid. We don't want to see the lights, sitting in here dimming and, going up and down. And, with something like that, you never know what you're going to get. So what we wound up doing is we used the energy storage system, one of our large scale batteries. We're like, well, let's see if we can turn things around fast enough to counteract what that's doing so that it winds up fitting what that nice little pretty curve would look like, and something that we can predict. So just to walk you through what would happen, the message flow of what would happen typically, with the setups that we have. Well, you get that big, wide swing in solar production. It either pops up real high or it drops off, because the cloud's coming. Well, we would have, a line sensor that would sit there and would, it would pick up that swing, but then what? Well, we kind of have to wait, because at some point the head-end system for that line sensor would actually go out and poll that device, where it may be 5 minutes, maybe 15 minutes, would poll that device, get that swing in solar. It would wind up going to some application in the back office to calculate, okay, here's what the battery needs to do. And it would turn around and send the message back to the battery. Well, guess what's happened in that delay? That cloud's moved. And it's nowhere, the power's not what you expected. So you've wound up sending incorrect set points to the battery. So they could both be pushing power and made things worse, or they could both be, power, drawing power, or not producing power, which you don't want either. So it's a very slow, data stale process, having to wait and go through all that. So, how do we fix that? That's what we needed to figure out. How can we turn things around? Let's go back to, the picture we saw a minute ago of all the siloed systems. Well, our concept was, we've got this big enterprise service bus, for doing integration in the back office. Why can't we take that same concept, pick it up, and move it out to the field? So this is what we wanted to do. We wanted to take, boxes and put them very close to the assets, our nodes. We wanted to put them right next to the asset so that we could push applications right out next to the edge and have these applications talk in amongst themselves out in the field to pull off a use case, to pull off a function. At the same time, though, we weren't cutting off the head-end systems in the back office. Data could still flow into the back office, into the head-ends like they always did, but we could actually pull off the use case in the field and have that very rapid turnaround of power here. So let's go back to our example again here, and taking it to the field interoperability. Well, out here we have that same wide swing in solar again. Well, we've got a meter that's picked it up. Well, that node is sitting right next to the meter, or right near the meter. He's sitting there. He's talking to the meter constantly. That he's pulling data about every 250 milliseconds from that meter. Okay, what's going on? What's going on? But none of that data's had to flow into the back office at that point. Well, as soon as he gets that wide swing in solar in that 250 milliseconds, he immediately turns around and tells the battery, "Hey, here, I need you to do this now." Well, the battery and at that point, the battery and the solar, the solar and the battery, they're actually following. They're doing their little tango dance, of following each other along, and it's working. But at this point, we still haven't updated the back office. We can still update the back office so that the models in the back office can still, see what has visibility into the field, but we've actually pulled off the function in the field and not have to put all of that burden, if you will, in the back office systems. Another thing in doing this, another little view of, our solar application here is, when we did this, most of the devices that we put out in the field, they probably have thousands of data points in them. They can measure and do all kinds of things. But we realized we only really needed like a handful of data elements to pull some of this stuff off. We needed, just some periodic reads off of these data, volts, amps, phase angle, a few things like that, so that we could see what's going on. We didn't need to pull, every piece of information out of these devices to pull off the use case. And we also needed, some, basic events every so often, like the switch opening and closing, when that would actually happen. So it wasn't a whole lot of data that we needed to be able to pull off these use cases. Well, now that we've got all this, information, these devices are publishing their data at these periodic rates onto this field message bus. You've got the capability of putting those distributed applications out in the field that can pull off the use case. You can do basic, analytics if you want to, even at the edge, to see what is actually going on without having to take all of this data into, a big lake in the back office. I'm sure that you guys have heard the term the data lake, from all the big data vendors, but you can do, smaller analytics where you may be dealing with a data puddle. It's something very, very small that you have in the back or, out in the field. Eventually you can push that data on into the back office if there's that business case for that. Well, another thing that you can do once you've got some of this data on this message bus that you're sharing, you can do things like some additional security. Now, I'm not talking about, your deep packet inspection and everything that, you've heard from some of the other security sessions that we've had this week, but I'm talking more things along the line does the power add up between these devices? Do all the kilowatts match what we think they are? If something doesn't match, we know something is, one, either wrong with the device, or it could possibly be getting spoofed. But it allows you to do some of those other kind of, things for applications on that message bus. So. All right, let's move on a little bit farther. We got the solar smoothing work. We proved it out that we can actually pull off this field message bus thing. So we came up with the concept of this coalition of the willing, where we wanted to actually bring some of our vendors in, have them have a little skin in the game to pull off a use case. We wanted to be able to take some of our partners that we work with, on a daily basis in our industry, and take them and let's go to Distributech. It's one of the largest, utility conferences that we have every year. Let's go to Distributech and let's see if we can pull off a distributed function right there on the show floor in amongst different booths. So we approached approximately 60 vendors that we work with, and these are IT companies, OT companies, telecom companies. We approached a lot of people to say, why don't you guys come and let's do this interoperability demonstration. Now, out of the 60, how many do you think that we actually got to participate? Anybody want to guess? Well, we got 6, so we got 10%. So it wasn't a whole lot, but we were hoping for more. But in hindsight, it was probably a good thing we only had 6. Honestly. So, but we got an integrator with Accenture. We had Alstom, which was a DMS system that we have, a distribution management system. Echelon provided meters to us at the time. Ericsson was our communication node that we were using. SNC donated cap bank controller for us, and Verizon was our communications between all the devices. So we used cellular between stuff. So we took these 6 companies, and we thought, okay, well, with these 6, what kind of thing can we pull off, at Distributech? So we wound up deciding, okay, let's do this little simple voltage management app. And what we were wound up doing, we were going to take the meters and we were going to vary the voltage that they would see and they would report and publish out onto the message bus. We would have the app that was developed by our integrator say, okay, well, the voltage swung this way. I need to either, open the cap bank or I need to close the cap bank. I need to do something with that cap bank. So it would send a message to the cap bank to do its thing over in another booth. But at the same time, we'd also send a message to Alstom's booth, for the DMS system to pick up what was going on. And so we went through all of this, and it took us a little while getting everybody onto the same page of what we're going to do, all through the legal mess that we had to do, so that we, once we got through all of that, it took us about 6 weeks to put this together. And so that's a pretty rapid turnaround for things in our industry. So it didn't take long. And we wound up going to Distributech, and we, successfully pulled this off on the show floor, where we had four or five different booths, everybody publishing and subscribing to data across Verizon cellular connections right there on the show floor. But we did learn a few things when we were doing this. The data models that we were using at the point, they were kind of awful. They were really bad, and it's one of those that we said we need to do better. But even though we pulled a lot of the vendors in, that we used, what we were doing was still kind of seen as a Duke Energy only solution. It wasn't some standard that people could actually go look at. So after that, we're like, okay, we need to start approaching some of these, standards bodies and stuff. We need to figure out how we need to push this so that other people can participate with it. Well, one of the guys that works with us, Dr. Stuart Laval, he's the one who actually coined the term OpenFMB, the Open Field Message Bus. So I wanted to give him a little bit of a shout out there. But we went through stuff, and we said, okay, how do we wind up going through this? How do we walk through this in a nice manner that people could follow along? So, we said, okay, you need to identify that business case. What do you want to pull off? You need to go document it. You need to model it. After you, go through modeling all this use case, you come out with some data, structures, data artifacts that, are relevant to your use case. Then once you have those, you can go build those apps on top of that. So it's a very step down process on how you do that. Well, we worked with, through the next year, we worked with the Smart Grid Interoperability Panel. It's a good organization in our space that we wound up in 2015. We worked through and we documented 3 use cases revolving around a microgrid, where we could island from the grid, we could reconnect to the grid, and we could actually kind of manage what's going on in the microgrid. So we documented that, very good. And then we took that. We were working with the North American Energy Standards Board at the same time, saying that we wanted to take this and provide it out as an industry standard so that other people could pick it up and use it. So we worked through all of that. We got people on board. We started down that road. Okay, how can we do this again? This Coalition of the Willing project that we did the first time, how can we do that a little bit better? So one of the things we want to do, we wanted more vendor participation in the next phase of this. We wanted at least 2 of every kind of vendors were applicable, where we had 2 meter manufacturers, we had 2 inverter manufacturers. We tried to bring in multiple people so that interoperability was very important, for everybody. We wanted to do that other, live demonstration on the show floor at Distributech. And with more vendors, it's going to be, a bigger issue. But at the same time that we were working on those use cases with SGIP, and we were talking to these vendors about this interoperability demo, we're also physically building a microgrid at Mount Holly, which is just about 20 miles right outside of Charlotte, North Carolina. We were building this microgrid to actually show these use cases, actually implement them so that everybody could see, that it wasn't, just something written down on paper. Well, we announced, that we were going to do this back in Distributech of 2015, and we were going to take those SGIP use cases that we were working on. We were going to actually implement them at our lab. We were actually going to demo them at Distributech. And this time we had 60 companies coming to us that says, how can we participate? Because they saw our first, iteration of this at Distributech. A lot of people didn't think that we could pull it off, but we did, and it gained some traction. And so at this point, we had 60 people coming to us. We couldn't handle 60 in a project. That would have been chaos. But it wound up, we wound up with about 25 companies that finished the project out, and you can see who and all those companies are. And a lot of those are companies that you probably recognize, because you probably have some of the same equipment in y'all's industries that what we do. So we did all of this. We built the microgrid. We got it working seamlessly, transitioning off the grid, back to the grid. We successfully demoed this on the Distributech show floor in amongst 10 booths this time, where everybody's publishing and subscribing to data on this open field message bus. And we pulled it off again. Also, at this time, we were able to announce at Distributech last year in 2016, that the OpenFMB process was going to be, ratified as a standard through NASB. And so in RMQ 26, if anybody's in the electric industry, you guys can go look to see what that standard is. And if you're not a member of NASB, I think it's like $250. It's not an expensive kind of thing to go purchase if you want to see what it actually is. Well, I just wanted to show you a few pictures about, where our Mount Holly microgrid is. The address is right there, but Google Maps still doesn't have everything updated. I just checked a few minutes ago just to see if it had updated. You still don't see anything if you go to Google Maps. Google Earth, I've heard they do have updated images. But you can see, where we, up in that top right corner, we had approximately 100 kW of solar up there. I believe it's about 118. We had a smaller solar carport in the box on the left, but we installed some grid equipment out there. We also, all of our actual microgrid stuff, like our islanding switch, our battery storage system and stuff was right there. But also in the building that you see there in the middle, that's where our lab's at, where we can actually do things, test things out. Just a shot of the yard that you see there, where you can see some of the things that I was talking about a minute ago, where we have our recloser that we used as a switch, our battery storage system there, and a few of the other transformers and stuff that we needed to make that thing work. One line diagram, if anybody's familiar with utility stuff, they do one line diagrams of what the power flow looks like and how things are connected. Well, we created this one ourselves internally. We didn't use any vendor product or anything to do that. So we just created a one line so that we could show off, we would have tours into the lab to show people what we were doing, to just show them what that power flow actually looked like. Now, this year, we're doing another project at our Mount Holly lab. It's going called Circuit Segment Management. You can see down in the bottom here, we've got our microgrid is still a portion of this. But what we've kind of done is we've kind of stepped up one level farther, and we're going to, take on looking at things that's happening on the whole feeder that microgrid's on. At the far top right, this particular feeder's got 1.2 megawatts of solar that's pushing back into the grid. That's creating that, crazy chart that you saw there a little while ago. We've got a battery system at the head of the feeder, that can inject power or pull power off of that particular feeder. And our whole goal is, can we utilize the microgrid as like a customer asset, where this would be something that a customer would own, not a Duke Energy asset. Can we utilize that asset to smooth out what's happening on this particular circuit? And last year we documented this particular use case with SGIP as well. So it's going to be another one of those things that we're going to put out there, for public consumption to see what we're doing. Now, a little bit, what actually is that OpenFMB? We've talked about a little bit about that. It's that distributed intelligence, that we want to put things out at the edge. We want to do things a little bit differently. But what isn't the OpenFMB? It's not a new protocol. It's not new data structures. We've actually taken the data structures that we already have in our industry. The common information model has a very rich a model of everything from customer systems in the back office through some of the devices in the field. IEC 61850 has a hugely rich data model for things that exist like at the substation. We take these models and we pull them back into our process to be able to go through all of our modeling and our documentation to pull off the use cases. We don't want to invent anything new if we don't have to. So we use the protocols that those devices already speak. A lot of the devices in our industry speak DNP3, they speak Modbus, they speak C12. So we utilize those, but we basically wrap those particular devices with those communication nodes. So from the communication node on the south side of that, it talks the old protocol to that device so that it can speak to it. But on the north side of that, we use more of the Internet of Things kind of protocols, the industrial Internet of Things protocols, like MQTT, DDS. We've used AMQP. There's a lot of these things that are already standards out there. So let's use those. There's no sense in us inventing anything new. So that's a couple of things, that it's not. But it's also definitely not, a crazy guy walking around at our SGIP conference in a Fox hat. So it's definitely not that. But so what I really want you guys to remember about, the talk today is OpenFMB. It's not anything really new. It's a reference architecture. And it's a framework. It's a framework of how you work through those use cases, how you document those use cases, how you come up with the data models for those particular use cases. It's that framework that helps you walk through that so that anybody can pick up and do the same exact thing in any industry that you're in. That reference architecture, part of what's out there in the RMQ26, it shows you, those first three use cases that we did in pretty good detail, and it shows you what those data models look like. It works you through that, steps you through that, so that you can see what that is. So it's a reference that people can pick up and move forward with. Now, if anybody really wants to get started, with this concept of open field message bus, you really don't have to go after everything. You don't have to go after a whole shop floor. You don't have to go after a whole generation facility. Kind of look what we did. We started with something as small as that solar smoothing, where we had two assets that we said, okay, let's put this kind of concept on top of a couple of assets. Let's do something small. Let's see if we can do this. Let's see if we can pull this kind of thing off. So you don't really have to, go whole hog and do everything at one time. And really work through the process. The process is really important for, you get not only people in your own company, but we had other utilities, we had vendors, we had, consultants. We had a lot of people around the table documenting these use cases and, going back and forth, said, well, we need this, but no, we don't need that. We had a lot of conversations, a lot of meetings around that to figure out what needed to be done. So the documentation and the modeling is extremely important. And part of that, really think about, don't so much think about what devices that you have, but think of what data needs to be passed around. Kind of think of, in a very data-centric point of view. Look at just the data that needs to flow between devices. You don't have to look at all of the data. Pick out only the pieces that is really relevant to what you're doing. Another thing, you don't have to go pull everything from these devices. They do a lot of stuff, but you probably don't want them doing everything. You really need them to do one particular function where you install that device. Leave the data there if you don't need it. If you have a business case for needing that data, by all means pull it into the use case, but don't pull all of it, because if it's not relevant to your use case, don't bother with it. Definitely don't try to invent anything new. And that's one of the things that we really strive for with all of our OpenFMB is let's pull from industry standards that already exist. Let's pull the best protocol for this use case. Let's pull the best data model for this use case. Pull those things in that you already have in your industry to do stuff. And that last bullet point there may sound a little crazy, but run things as slow as you need to. If you don't need a reading every 10 milliseconds from a device, by all means don't pull it every 10 milliseconds. If you only need it once a second, pull it once a second. Run that particular thing as slow as you possibly need to. If you don't need the data deluge coming off of that device, don't pull it, don't need it. A couple of little places that you can go to get more information on OpenFMB. We actually, in conjunction with SGIP, we worked on a OpenFMB collaboration site. It's openfmb.io. that you can go out and get more information about what OpenFMB is, that you might not have heard today. We've also started an open source code repository where we're putting, Duke Energy's put some applications out there. Some of our vendors that worked on the projects with us have donated some open source software so that people can, start with something. There's an adapter there that will allow you to take DNP3 reads off of a device and turn that into a data model on the other end. So those kind of applications are already out there. And also, if you want to know more about the Coalition of the Willing project that we just wrapped up last year at Distributech, you can go to duke-energy.com/coalition, and you can get a lot of good information about that project and how it went. And with that, that's all that I have today. So hopefully you guys will have some good questions for all of us here in just a minute. So I really do appreciate your time this morning. Thank you.